In this lesson, you will be provided with information about the characteristics of hydraulic seals, as well as the various types of hydraulic seals. You also have an opportunity to see how these types of seals work, and what the main considerations are when choosing a hydraulic seal for a particular application. Click on the Next button to continue. Seals are devices for closing a gap or making a joint leak tight. Seals also prevent fluid from leaking out of the system. Lastly, the seal also makes it possible to transfer forces within the system. These are the main characteristics of a seal. Trelleborg Sealing Solutions has developed innovative sealing systems for demanding industry applications with a focus on leak-free performance and long service life. When talking about hydraulic seals, we think about an entire system of sealing elements for rod and piston. The interaction between individual sealing elements needs to be guaranteed in order to create a reliable sealing system. Click on the tabs to learn more about the functionality of rod and piston sealing systems. The piston sealing system consists of a piston seal and a number of wear rings. The piston seal seals the dynamic surface between the piston and the bore. Piston seals are normally double-acting, which means that they are symmetrical and conceal pressure from both sides. The wear rings center the piston, guide the reciprocating movement, and protect the seal and metal parts from damage. The rod sealing solution prevents leakage of hydraulic fluid from the system. With the help of the scraper, it also prevents dirt and pollution from entering the hydraulic system. The seal that will face the whole system pressure is called the primary seal. The secondary seal will only face a smaller pressure and can be made from a softer material to add sealability. Rod seals are normally single-acting, which means that they are optimized to seal pressure from one side. A hydraulic sealing system consists of 4 parts: piston seals, rod seals, scrapers, and wear rings. The 4 components of a hydraulic sealing system have very specific functions. Click on the images for detailed information about each component. In this example, you will see a typical piston seal that is double-acting. Double-acting means that the seal is symmetric and designed to seal pressure from both sides, which makes it possible to extend and retract the cylinder. Rod seals are external seals used to avoid leakage of hydraulic media out of the system. This sealing system consists of 2 rod seals. Rod seals are normally single-acting seals, which means that they are asymmetrical and optimized to seal pressure from only one side. When you use 2 rod seals, it is possible to optimize the performance for each seal. The primary seal is facing the internal pressure, and by using a harder seal material like PTFE, you will combine extrusion resistance and low friction. The secondary seal will only face a smaller part of the system pressure, and here you can use a softer seal material like polyurethane to increase sealability. Scrapers or wipers work within a sealing system to keep dirt or other contamination out of the system. Scrapers can have single or double-acting functions. A single-acting scraper has only one function: to keep contamination out of the hydraulic system by scraping or wiping the rod. The double-acting scraper also adds a sealing function towards the oil side. Scrapers are made from different types of material, such as rubber, polyurethane, or PTFE. The broad variety of materials and designs makes this component optimal for different types of scraping. Wear rings, also known as guide rings, are used together with both rod and piston seals to guide the components and avoid metal-to-metal contact. By absorbing load from the system, the wear ring protects the seals and hardware components. The dimension of the wear ring can be calculated based on side load and temperature in the system. Trelleborg Sealing Solutions are using the name slide ring as a brand name for wear rings. Requirements in a hydraulic system are something that needs to be fulfilled and should not be compromised. Both hydraulic systems and seals have requirements that should be considered. In the coming slides, we will speak about pressure, hardware, and general system-related requirements that will help you in the selection process, so you can find the best sealing solution for your application and needs. Ask yourself, can you assign the correct seal to your requirements? Pressure is one of the limits of the seal. In Europe and Asia, megapascal or bar is commonly used. In the US or UK, PSI or pound force per square inch is used. Once you know the pressure limit in your system, you can start to think about a seal. Different equipment has different pressure ranges and therefore also different sealing systems. You can see some examples of pressure and applications on the screen. The expectations for a hydraulic system lifetime or service life are normally quantified, as you can see in the example, and this can be a requirement for the product. But how can you get your system to live up to your expectations? The answer to the question is that the hardware is one of the most crucial aspects to consider. The better the conditions at the hardware level, the better the seal will perform. In this slide, you will learn more about installation dimensions based on information in our hydraulic seals catalog. Click on the circles to get more information. We will use a 200 mm piston seal named Turcon Glide Ring T with the part number PT040200 and 15 MPa pressure as an example. The bore, the groove width is 8.1 for PT04 and the radius, radial clearance. If the pressure is during the construction and procurement process, it is essential to think about the seals and the system requirements. Resistance against extrusion, efficiency in terms of cost and performance, low friction, easy handling and assembly, stability towards temperature and media, compliance with industry standards, and reliability in terms of both performance and logistics. Keeping these requirements in mind will guarantee optimum results and an efficient construction process. Point at the displayed terms to get additional information. You know by now that sealing elements have a significant influence on the function and service life of hydraulic cylinders. The main challenge is to match the requirements like pressure, hardware, expected lifetime, and conditions of the hydraulic system to the correct choice of seals. The more system information and requirements that are available, the easier it is for the Trelleborg Sealing Solutions contact to choose the correct seal for the application. If you have any doubts regarding a sealing solution, always contact your local Trelleborg Sealing Solution office. What is friction? Where does it come from? And what does it do? The next slides should help you to understand the basic principles of friction. Try rubbing your hands together. What do you feel? When two surfaces are rubbed against each other, heat is created. This effect is called friction. You'll find that the faster you rub, the warmer your hands will get. If you increase the speed, you will increase the temperature in the system due to friction. The compression of a seal in the groove is called squeeze. The level of squeeze is a balance of friction and leak tightness. The aim is to squeeze the dynamic seal so it seals in a good way and compensates for the tolerances in the system, but not so much that it creates problems in terms of friction heat and material stress that will reduce the seal's lifetime. No squeeze will create the lowest friction, but the seal will not be able to seal. When you apply medium squeeze, the seal can still move, and it will generate some friction heat. A seal with a high squeeze level will create much friction heat, and it will be harder to move the application. When you apply medium squeeze, the seal can still move, and it will generate some friction heat. No squeeze will create the lowest friction, but the seal will not be able to seal. The previous slides mention speed and initial squeeze that generates friction heat. When you add the system pressure from the oil to this example, then it looks like the conditions in a hydraulic system. If the hydraulic system is run frequently with high speed and high pressure, the system will generate heat. Dynamic systems will always create heat due to friction, but you would like to have this under control. Therefore, it is important to use low friction seals, proper hardware, and sufficient cooling and circulation of the media to ensure the function of the sealing system. In the coming slides, we will talk about the lubricating media and the effects of the lubrication film and leakage. In a hydraulic system, there is normally an oil to transfer the force. The lubrication film that is created between the dynamic seal and the counter surface is important and helps keep friction and wear low in the system. Oils should be carefully selected, together with an oil specialist, to match the demands of the application. In the case of stick-slip, the dynamic seal does not automatically create the oil film between the seal and the sliding surface. The oil film is important for an even movement. The seal will create a jerking movement, and this phenomenon makes the seal stick and slip. To avoid this problem, Trelleborg Sealing Solutions recommends the use of special low-friction materials like PTFE. All materials have their limits, and seal materials can fail when this limit is exceeded. But how sensitive is a seal to temperature? Click on the buttons to see how different temperature conditions can affect the seals. An old rule of thumb for elastomer sealing materials is that for each positive 10 degrees Celsius you add, you decrease the lifetime of the seal by 50%. If you exceed the maximum temperature, the seal will be permanently damaged. Low temperature can lead to leakage because the seal loses its elastic properties. Low temperature should not damage the seal, and when temperature is back to the working range, it will seal again. The word extrusion means the tendency of a seal to flow into the clearance gap between the seal surfaces under pressure. Extrusion is essentially influenced by pressure, and this can be a problem in some applications. Normally you can solve this problem by replacing the seal with something that is more pressure resistant, such as harder seal materials or corner reinforced seals. Decreasing the gap and pressure are other alternatives. The lubrication film is important in a dynamic system and helps keep friction and wear low. Wear can occur on different parts of the system for one or more reasons. The most important thing is to find the source of the wear and remove this from the system in order to regain a healthy system. The reason for the wear can come from tough working conditions in the application, but also from contaminants, bad guidance, or wrong hardware design or quality.